Hi guys, I'm Kim Emerson.
And I'm Katie Hardister, and we are the Irrational Duo.
This is our Teen Teach 1 over Chapter 8.
We can jump on in.
All right, so I see here that we have a graph and then we also have a scenario. So Katie, can you demonstrate for us how we would label our X and Y axis?
Absolutely, Kim. So the way that we would do that, really with any graph that you're going to label the X and Y axis, you really just have to look at the scenario that you're given because it could be anything and it just all depends on the scenario. So for instance, this scenario that we're given is to explain a graph to correlate with the amount, to explain the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. So whenever I look at these, I definitely want to encourage the students to always underline the important information. In this case, I would say, what are we looking at? What are we wanting to know? So we're wanting to know how many gallons were used of gas, and we're also wanting to know the distance. Would you agree?
I definitely agree. I
So
think
the only question is, where were we going to put it?
Mhm.
So I would say that down here on the x-axis, we're going to put the distance.
So meaning distance, does that mean like like in kilometers, meters, miles? What would we use for distance here?
Well, typically the equation or the scenario will tell you, it will specify exactly what it wants. But if it doesn't tell you, then it's kind of fair game for whatever the student interprets it as. So
Yeah.
it could be inches, it could be feet, whatever they want. For me personally, I am a driver, so I know that we drive. We measure distance typically in miles when we drive. So
Yeah.
for me personally, I would say the distance in miles.
Definitely agree. Is that what you would encourage your students to think about is like actual mileage when it comes to
Yeah, I would say, whatever relates to the student the most to help them have the best understanding. So, just
definitely.
depending on the age group, wherever we're at. So I'd say distance in miles. And then we're wanting to know the gallons of gas used. Whenever and we would, of course, put this on the y-axis. And I know that you are going to kind of explain that more for us.
Yes.
I would just say that whenever we are, teaching students to label the X and Y axis, just again, encourage them to read the scenario, underline important information, read it once through, read it again and underline things. And
Definitely.
then, make it relatable to them. There's no right or wrong in doing so, as long as you follow the scenario.
Definitely agreed.
So moving on to the next portion of this, how would you explain this graph to students, Kim?
Starting off by what you said, we labeled our X and Y axis would always be the first step to do. That way you know what you're like looking at, what the graph is all about. So
Mm-hmm.
to actually understand the graph, we see that we have distance in miles. So we see the mileage that the car is driving over time. So you see
Mm-hmm.
how many miles. All
Mm-hmm.
right, and then looking at the y-axis, we see the gallons of gas. So how much gas is being used over how many miles?
Mm-hmm.
So let's look at a little example. So if we have a little car on our graph and we
Mm-hmm.
see that it is driving and it stops to fill the gas up, the gas will go up, but the car's not moving. And
Mm-hmm.
then once they're driving again and you see how it escalates in miles, then you're losing gas. So
Sure. So they're gonna drive here, and when it hits the low point, they're running out of gas. It
yes, and
feels
they'll fill
straight
it back
up because they're not moving. The distance isn't
up.
moving. It's
Mm-hmm.
just the gas, the
Yeah,
gallons of gas that are used in the car. Okay. Well, let's see if we're right. I would
definitely.
say so. Looks like a fun family vacation to me.
So since we did the first example and we kind of know we got a good grip on it, so how would you label this X and Y axis with this scenario?
Okay, so for this one, we want to explain the graph to correlate with the function of the height of the elevator. So again, we can underline that. We are looking at the height of the elevator,
Yes.
stopping at each floor on the way up. So for that, I would say that we are going to be labeling the x-axis. I would say again that this is the time spent on the elevator.
Yes.
And then I would say on our y-axis, it gives it to us right here. This is going to be the rise of the elevator. Now,
Yes.
I could say the height, but
Yes.
I wouldn't say that the rise of the elevator is kind
Okay.
of the same thing as saying the rise
Mhm.
um, of the elevator.
Yes, I definitely agree with that, and I love that you keep pointing out that they need to highlight, underline, and reread, like, the key points that stand out to them when it comes to labeling the graph, because it makes understanding the graph so much easier.
Absolutely, I would agree. All right, but how again would we explain this to students?
So, I mean, you kinda got the key points, you see that we have, how much time is spent, when the elevator is stopped and going up, and then we see the rise of the elevator. So,
Mm-hmm,
if we see that the elevator is stopped and we see the little line that's like this, the horizontal line, that
mm-hmm,
means that it's spending time to let people off and on the elevator. And then
mm-hmm,
once it's going back up, it's going up to the next floor. So we have the first floor, and then we have the second floor, we have the third floor, and then we have the fourth floor, and so on and so forth. You'd see how many floors we have. And then you could also see,
mm-hmm.
time where it lets people on and off again. So
Yeah.
yeah, it's pretty self-explanatory. And I think when you look at this graph, it's a little bit easier to understand it, especially seeing we labeled the X and Y axis better.
Yeah. So we could see that this is definitely going to, see how many floors this elevator goes up. So I would say it goes up at least 5 floors.
Yeah.
So that's a fun little interactive way for the students. We
Mhm.
could count, we could also even relate this, change the scenario and say, how many flights of stairs did they
Yep.
have to walk up, because this could definitely be, a flight of
Like
stairs in
stairs,
here.
elevators. I mean, it could
Hmm.
be, and
Yeah, it could be
like this
anything.
graph could go to any scenario. This is just our specific one. I definitely agree with
Absolutely.
you.
Yeah. All right. So let's take a look at another scenario.
Yeah, and then this one we're gonna label the X and Y axis again. Katie, you're gonna show us
Mhm.
what we're gonna do that with.
Again, this is our X and this is our Y. So let's read our scenario. So explain a graph to correlate with the function of the height of the bouncing ball when it's being dropped from a table. So we're going to drop a ball and it's going to bounce on a table. And we want to know ultimately what is the height. And I think I ended up saying we could best describe this as the range.
But, I mean, I think you're perfectly right. I think you could say it's the height because that's what it is. I just think a more, on an education level, it could just be described as range, like you did in, just any other
Hmm.
word. I think it's just a big word for height.
Yeah, I think it all depends on the student's level and their vocabulary. And then I would say that this is definitely time,
Mhm.
like you're going to explain. We'll
Yeah.
see in a minute why we chose time. I don't want to take your
You're
question.
fine, you're fine.
So how would you explain this to students?
So, seeing that we have time, we have range, which is also, the same word as height. We see that we have a ball that is
Hmm.
dropped, and then we see the time frame of when it's dropped and the height of it. So, that meaning that the longer it's bouncing, the smaller the ranges of the bounce. So,
Hmm.
if we click on our little purple ball, we'll see that once it's dropped, oops, sorry, um, just visualize once it's dropped, once it starts
Hmm.
bouncing, it's gonna hit the floor, it's gonna bounce up, and it's gonna keep continuously bouncing slower and slower until it's just stopped.
Hmm.
And then that
Yeah.
will be the end of the bouncing time. So, I
Yeah.
mean, it's pretty self-explanatory. I mean, you could even do an example at home with a bouncy ball, or if you
Yeah,
have,
I was
you know
gonna say that. I think that if I was in a classroom, I would, make math a little fun,
yeah.
and have the students drop the ball. That's a great way, or let them go outside and let
Yeah.
them draw the graph. Just
Mhm.
to kind
That
of.
would be a great way to get them to visualize it because graphs aren't always as easy to understand, as
Mhm,
us as adults. But that's a great I think kids love visualization and love to see things actually happen in motion.
absolutely. Well, jumping on to the next one.
So, how would you label this X and Y axis pertaining to the scenario?
Okay, so again, we're going to explain a graph to correlate with the function of the length of a shadow um, of a flagpole length
Mhm.
of a shadow of a flagpole throughout a sunny day. Man, that's a tongue twister. So we know, of course, that the sun sets, rises and then sets. So it makes like a big upside down U shape. Um, for this one, I would say, we're wanting to know the length of the shadow. And again, the time of the day. We know that the shadow, the sun, it
Yeah,
moves throughout the day. So I would say the time of the day or the
definitely.
hour of the day. And I would say that this would definitely be the length. Again, it tells us right there. Hello, I can't write the length of the shadow.
Yes. And I definitely agree with that. And I feel like, that one may be a little bit harder for students to understand and comprehend that, which could be also be a very good exercise where you go outside, look at
Mm-hmm.
look at your school's flagpole, because most of us here in the US have one. So,
Mm-hmm.
go outside and, go later on when the sun's either going to be passing over the flagpole,
Mm-hmm.
so you could see the length. And I'll go into more about that in the next slide. We'll
Yeah,
see.
you could even, take and make it an interactive, let them like take a lamp and make their own sun,
That's very,
and
very good.
definitely maybe even talk, with your science teachers, if
Yeah,
they're, teaching the same thing and kind of bring math and science together, you
that's a
know?
great yeah, I definitely agree with you.
Yeah.
So
So
explaining
how would you explain this to the students then?
yeah, yeah. So, I'm gonna try to explain it the best of my knowledge to interpret it, but,
Okay.
explaining the graph, the sun comes out, it rises, but the the shadow of a flagpole or any moving object or any object, it's gonna have a different length of a shadow, different times of the day due to the sun moving constantly, you know what I
Hmm.
mean? So once it rises, the longer the shadow, the closer it gets to that object, the smaller the shadow. And once it's directly over that object, you're not normally going to typically
Yeah,
have a
it doesn't
shadow.
have a shadow.
But yeah, but once it passes, you don't have a shadow after
Hmm.
that. It's just the longer it is, the closer it gets to it, the shorter, the further away, the longer the length. And
Yeah.
that's a good example. I mean, it's just the graph might be a little bit hard to visualize that, which is a good way to,
Hmm.
it would be
Yeah.
a good visualization to see
Hmm.
that happen.
When we did our homework over this, they gave us, of course, all four of these graphs side
Mhm.
by side, and they gave us, of course, the scenarios and lined them up. So I had a little bit of trouble with this because I
Mhm.
had a hard time in the beginning. I thought, well, this graph is wrong. It should be reversed, and really, I just used process of elimination for
Yeah.
each of these in the beginning because I wasn't quite sure. And once I used process of elimination, then I could understand
Yeah, and I
why it
definitely
was
agree
that.
with that. I was a little, I mean, it's that like you said, and like I said, graphs are a little hard to, to understand fully without actually knowing the
Yeah.
scenario, or you know what I mean, without
Hmm.
seeing it. It's just hard to interpret.
Yeah, absolutely. Well, let's
Definitely.
jump right on over to the next thing.
So looking at this, I see a chart and I see a graph as well. This is a different kind of graph. This isn't, this one doesn't necessarily have a scenario. It has a function, and
Hmm.
you have to fill out the chart for it. So could you show us how to plot these functions on the graph?
Sure. So, what this is, and at first looking at it, it's a little confusing because you think, well, here's a function, here's another function that looks crazy.
Mm-hmm.
Um, all it is, though, it's
It looks
scary, but
scary.
f of x is just a really fancy way of saying y. So you could rewrite this, and I do this on my
Mhm.
own personal time. When when I see f of x, I immediately think
Mhm.
why.
Why?
Yes, why. So I rewrite it and I say y equals 3x.
Mhm.
And then this one here, oh my goodness, look at all those parentheses. Let's cross it out and say y. And
Yeah.
we know, and look, here's y again. equals 8. And I know that you're going to go over
Mhm.
it, you know, and you're going to show us exactly how, you know,
Mhm.
to work these. But to kind of, um, you know, make this make a little bit more sense, what I did is I split my page and
Mhm.
I said, of course, we have X and we have Y. I can split this here. And I have X and I have Y.
Mhm.
Split
See, I
that
get a
there.
little confused, seeing 3 rows of,
Mm-hmm.
when you look at this chart, you don't think of 2 different lines. You just think it's 1 line because it's all in one, one data table. So it's just a little confusing.
Mm-hmm.
And I feel like if you don't go into depth in explaining it to your students, they will get very confused,
Yes.
you know.
Yes.
I
Well,
mean, even
Kim,
still, I got confused. I wasn't really
mhm,
sure.
mhm. Well, all they did here is this is
Mhm.
the same thing as writing this here. This is a table and this is a table. All
Yes.
they did is combine those X's.
Yes.
So we just have these numbers here. Forgive my table, it's not very pretty, but
Oh, it's
that's
perfect.
okay. Um, all we did here was we took these. So here we can plot them. We can say, and this is this one here. And
Yes.
then this one, it combines X, of course, and then this Y. So we could plot 0, 0, go over 1, up to 3. Now,
Mhm.
Kim, what about this right here? There is no 3.
Oh, I mean, you just automatically know that the 3 is in between
So they're
because
counting by twos.
you're going by 2, so you gotta think of
So
halves.
there
Every
is a 3.
half is
It's right there. And there
yes.
is a 5.
And,
It's right
you know,
there.
that might also be a little bit confusing, but I feel like
Mm-hmm.
that's more understood than what you know what I mean?
Mm-hmm.
By 2s or even if you just go by, if you go by 5s, you gotta know
Absolutely.
that's
Yeah.
the
It can
actual
definitely be confusing, though, to students at first.
no,
Um,
definitely.
but as far as plotting those points, I know you're going to go a little bit over, you know, actually solving the equations,
Yeah.
but just kind of simplify where you need to. There is no harm in doing that using paper. Let's jump right
Oh,
on into
you're
yours.
perfectly fine. So
How would we solve these?
so to solve the functions, I'm Katie, would you mind drawing for me? Sorry.
Absolutely. No, no problem at all.
So if you like Katie said, you can see that f of x is equal to y. So we'll go down there at the bottom, we'll write y equals. And we see that we have our x column with all of our x points, and we are going to plug in x for, in the function for y. So we see, y equals 3x. So we're going to put parentheses and put in 0. So
Mm-hmm.
y would equal 0. 3 times
Mm-hmm.
0 is 0. So our y
Mm-hmm.
is 0. And that gives us a set of points, and we could even do, we could check that off and go to the next one. And we see, that we have big bunch of parentheses, and that really just means y. So we have, y equals f of x, which is just y, and that equals 8. So we see we have our point would be 0, comma 8. So I mean,
Mm-hmm.
really, data charts are very, very helpful because, it helps us label what is what in a function for y.
Mm-hmm.
And it
Yeah.
helps us have a better understanding when we're looking at a graph. We want to know where we got those points from, how we got those points. And so,
Absolutely.
you could always double check your work.
Yeah.
Always double check your work by plugging in for X. I mean, most of the time we
Mm-hmm.
have
So this
calculators.
is definitely just a plug and play.
No, definitely, definitely, definitely. So it shouldn't be too
Absolutely.
complicated. It takes time and process.
Absolutely.
So let's look at our next question. So we see, we're going to talk a little bit more about slope now.
Mm-hmm.
So before we go on talking about slope, can you explain what a slope is when it's undefined?
Yeah. So the slope here, I have my little example there, but it's a little hard to
Mhm.
see. So I can try to redraw this. Forgive my lines though.
Oh, you're fine. You're fine. I can see that example great.
Okay. So here's my X and Y axis. And we know it, of course, goes on and on and on forever. There are different coordinates. So all it is whenever I see a line that is vertical up and down or horizontal this way, I know that there is no run
Yes.
here on this vertical line. There is no run. So I automatically know that there's an undefined slope. There's no,
But
because it's,
how would you explain that to students? I mean, because, we see that and we see, that it's just a rise, but,
mhm,
you
yeah.
just explain that to them and more into depth.
Yes. Yeah.
Mhm.
And, you know, even seeing whenever it has a 0 on the bottom, whether
Yeah.
it's positive or negative, if it has a 0 on the bottom, it is going to have an undefined slope.
Okay. That
So
makes
the answer, if whatever this question may be, you would just write that it's undefined.
So I have a question. So, looking at your example, so I see that you have the change of y over the change of x. So that means the slope, right? So the change
Yes.
of the y and the change of the
Mhm.
x. So if we see, over there to the right, we see the change of x equals 0. So that's what you're pointing out. If you see that the change of x is 0, that means there's no
Yes.
sign. There's just a rise. That makes more sense.
Yes, ma'am.
Makes more sense. That's a great way to, explain to your students.
Yeah. Well, thanks, Kim.
You're welcome.
So going on, are there multiple methods to finding slope, Kim?
There actually is. There's a various, amount of methods. I'm just gonna put 3 on here.
Mhm.
The top 3 is rise over run, which we all typically use just because it's so easy to just be able to visually see how many times it's going up, how much
Mhm.
it's rising over, how much it's running over the x-axis. So,
Mhm.
but there's
So what does
also
that look like?
so that means, you see we have our little right triangle. We see
Mhm.
that we have it going up 1, 2, 3, 4 times.
Mhm.
So we label that as our rise. So that'll be 4 over, and then no, 4 would be the rise on top, and then the
Oh.
run would be 2. Sorry. So we'd have 4 over 2, and then you just do math from there. So we see 4 divided by 2 equals 2. So that means we have a slope of 2.
Mhm.
And then we can also just throw it into slope-intercept form, and you'd see mx, and that would be the slope. But we're
Mhm.
just going to go ahead and use lattice points. So this
Okay.
I learned from another scholar. I didn't know about this, which is a great way to do. I teach
Yeah.
and just do rise over run because I'm lazy. But you always want to show your other students,
Yes.
that want to do it. other.
Yes.
So we can go ahead and label our points. Um, so so x.
So by our points, you mean this point here and this point here?
Yes.
Okay.
So we see that we have x1 would be 3,
Okay.
and then
So x1 would be 3. So we're calling this set
yes,
is our 1 and
yes, ma'am.
this set is our 2,
Yes,
right?
ma'am.
Okay.
We could just throw it in there, but I want to visually let the students see it. So we're gonna open up some parentheses and label our x and y.
Okay.
Our x1 would be
So
3, comma, um, uh,
is that what
sorry.
you mean?
Yeah, I was should I how would you write this? Because there's multiple ways to write it
Mhm.
and just be
Whenever
quiet.
I do
Yeah.
this, personally, I like to, even though it's in the graph here,
Mhm.
this 4 here just confuses me.
Yeah,
So
because you have
I
black
always, I rewrite it and I say, this is going to be my set of points
mhm.
1,
One.
and this is going to be my set of points 2. I know
Definitely,
that this is
I agree
X.
with that.
Mhm.
Makes more sense because you see all these numbers and you just get so confused, and I feel like
Yes. And
this is
there's
really
no,
students
yeah.
because there's so many ways you could get confused here. Looking at it
Mhm.
when you're trying to label all these numbers. So
Mhm.
I would definitely show them how you're supposed to label them and how they are in a function.
Mhm.
So looking
So
at this,
from here, I know that we take y2. So that
yeah,
would be, I'm going to look at my y's.
hmm
This is my set 2, so I know it's this one here. So
yeah.
5.
So
So
we have that.
5, and it's minus y1, which is 1, over x2, which is 5,
-3.
minus
Mm-hmm.
x1, which is
Next one.
3. And then from here, what do we do?
So yeah, you would just do, your basic subtraction. You would do 5 minus 1, which is 4, and then that would be over 5 minus 3, which is 2. And you see we have a pattern here. Look at our rise over run. We see that's how you know you're doing it right. So you could do your lattice points and
Mhm.
you could double check it with rise over run. You know what I mean? You
Mhm.
can do it multiple ways. And
Yeah.
then divided by 2 is 2. So our slope is still the same. We have the same, example here.
Mhm.
That's a good way, you're doing it right when you end up with the same.
Absolutely. Yeah. Well, that's a great way. I'm so happy that there's different ways because,
Yes.
for different, I've, solved some, finding the slope that the numbers are just ginormous, and it really, you could just cut out this graph altogether and you could be given only points.
Yeah, and then you could
Then you
still
can't
find
calculate. then you can't count, you know? So you have to
So
put it
rise
into a
over
lot of.
run would really be, I mean, if you didn't have you know,
Mhm,
that's a great example. I love that you point that out because if you didn't have a graph and you weren't able to visually see it, then
mhm,
you couldn't do rise over run. You don't know, you
mhm.
can't see it. So that's a great way, and I'm glad there's other ways that you can find the slope.
Absolutely, I agree. Let's
Well,
take a look at this next one here.
so now that we're talking about slopes and we're finding them through our functions, right? And
Mhm.
we're finding our set of points through our functions. Well, before we go on, we got to know what a function is. Can you explain that to us, Katie?
Sure. So a function is exactly what we were doing earlier.
Mhm.
It is literally just there what I have circled. X squared minus 7, that is our function.
Yeah.
Again, all we would do is just take, of course, this 3 here, and we would plug it into x, negative 3, plug it into x, that's our function.
And
So function for y, input x to get our y. So this is, finding our y right there.
yeah,
Oops.
and that would be the same as, f of x. So like we
hmm
explained that. So I mean, we just went ahead and put y, you know what I mean? But you just put the x instead
hmm
of the
Yeah.
y equation to solve for y.
So the function f, that means f of x
Yes.
right here.
That means, yeah, also
Same thing as y.
yeah.
Absolutely.
It's
Yeah, I
not
think, aren't these called number machines or?
um I really don't remember. I remember okay, I I think I remember, but
Uh-huh.
I don't
I
know.
think they've been called a bunch of different things, but I
Yeah.
know I was in a class one time and I saw that they actually took a ball
Ooh,
and it had a function on it, or
oh,
no, maybe the function. I remember what it was. It actually had, I think it was like a tissue ball, a tissue box with a piece
uh-huh,
of cardboard in the middle, and they would put a ball with a number on it into one side, and it had what the function was, and then
yeah.
the students would have to guess what was in the machine, and
Oh,
then the teacher would pull out the ball out of the other side and it would have, the number.
that is a great way. Like I said, I mean, everything, I feel like everything is, sometimes it may be really, really difficult to find
hmm
hands-on or visual things for your class to do. I feel like that's just a big,
Yeah,
big,
children love to put their hands on and get
anything.
in there,
Yeah.
and I love making things relatable to like real world scenarios,
Yeah, no, I definitely agree with that. Like
Yeah,
I
absolutely. Well, let's take a look. So how does a function relate to a graph?
Well, I mean, we've kind of been doing this the whole time without even realizing it. We're
hmm
realizing that, I mean, we're realizing that we're solving a function to get a set of points. By
hmm
getting a set of points, I mean, we're solving, putting in our f of x to solve for our y. Well,
uh
what does our y do? I mean, our y is a set of point, is a point
hmm
in the graph
Yeah.
along with our
So
set
when
of
we solve the function, it's giving us our y point. So
yes,
we have our x, we're
yes.
getting our y. All we do is plot the points.
Yep. So seeing our
Okay.
functions on the left, if we solve those with, if we were giving whatever numbers of x's we were giving, we'd solve all of those functions and get our set of points, y comma x. And looking at our parabola table, we see, we have all of our set of points from a function. So,
hmm
and that's what makes our graphs. You know what I mean? A function is what our graph is. It explains
hmm
what our graph is in number.
Absolutely. Yeah.
Another one. Let's look at so, we're talking about a lot about slope functions and graphs. So let's talk about what kind of different lines there are in a slope,
hmm
in a graph. I mean, in general, what are our
Yeah.
general lines?
Just different kinds of lines in a graph.
Mhm.
Sure. So whenever we see different types of lines, I know that there's intersecting lines. Intersecting lines is a lot of what we've seen here today. It's just plain and simple when they intersect. Um, Now, not to be confused with, and I guess it's kind of one and the same, but not. So perpendicular lines, yes, they are intersecting lines. But a perpendicular line is a right angle only.
Okay.
So it has to have a right angle. It has to make a perfect box. Now, I am not going to draw a perfect box, but we could take a box in there and put it right there and it would be a perfect right angle. Whereas parallel lines, I think that it's super duper cool that parallel lines gives you a hint right here with the two L's.
Mm-hmm.
It tells you in the name that they're parallel, they go on and on and on forever, and
So
they're
I think
never
the
going to touch.
visual represent seeing those little things, those little things stick to children's minds so easily. I mean, that's what
Absolutely.
my whole life.
Mhm,
Parallel means, two lines that are continuous. They never cross. Makes a
mhm,
lot of sense. I mean,
mhm. I love to pull up whenever I'm, with children, and, going over lessons. I like to, when we're walking to the lunchroom, we can talk about how, or even just like walking out to recess, whatever we're doing, we can look down at the ground and we see the tile on the floor and we can see here's intersecting lines. What if we took up the lines in the middle? Well, now there's parallel lines,
yeah,
and there's perpendicular lines, and
yeah.
pointing out to the children where all of these things are that are all around
Mhm.
you.
No, it makes a lot of sense. I mean, I totally get it.
Okay.
So
So
let's look.
jumping on, just connecting it to real world. So how do I find a negative reciprocal though?
Ooh, see,
Mhm.
I love when we're given like maybe not like so much of like equations, but I love when we're given a like kind of like a formula, say
Uh-huh.
not really a formula, but
Yeah.
because it's like solving something and it makes it fun and interesting. And you know
Mm-hmm.
what I mean? It gets them interacted. So this is called flip the switch. So one
Yeah.
turns the light on, one turns the light off. One's positive, one's negative. So kind of just
Absolutely.
flipping the switch. So we have A over B, and we're just gonna write an example, and we're gonna look at this, and we're gonna see A
Mm-hmm.
over B. So we're gonna throw down some numbers. So let's do
Sure.
3/4.
Okay.
All
3
right.
over 4.
Yes, ma'am. So we're gonna start by flipping the reciprocal, which I mean just switching the two numbers. So
Okay.
that'll equal to 4/3. And you see how like it's step by step. So it's kind of a small, easy little thing, but it's still you still have to follow the steps or you're not gonna get it.
Mm-hmm.
And then easy as it could be, you just switch it to negative. You switch the I mean, this could go for a negative number. You could find the positive slope by, you know what I mean, the positive
Mm-hmm.
reciprocal,
So we could say -2 over 1, and then switch it to 1
one.
over 2, and
Mhm.
then switch it to just 1 over 2.
Exactly. I mean,
Yeah,
it's pretty easy. But I just think it's fun to look at different numbers in different ways.
absolutely. I had a teacher in college, and he taught my college algebra, and he said something that was silly even to college students that I definitely will be taking with me to my elementary classroom. And he
Uh-huh.
said flippy floppy, and I've never heard so many adults laughing because he would do a little flippy floppy, and I
I think
just think that little sayings like that really stick with kids. It stuck with me. So, well, going on to the next one, what is a tangent line? I will tell you.
oh, please do.
Um, so, a tangent line is a line, it's a straight line that touches a curve at one point.
Mhm.
So we see here that um, it's a straight line here,
Mhm.
and it's touching a curved line here. So we've got
Mhm.
a tangent line at this point.
Yeah.
And at that moment, when they meet, they're actually sharing the same slope.
Yeah. And
So
would that be like the same set of points as well, just because
yeah,
they're connecting at
mhm,
that,
yes. So
that
they
set?
share points, they share slope, and they're touching just the one time. So we
Okay.
see here that this would be our tangent line. This right here is not a tangent line.
Yeah. Yeah.
Yeah.
Because it has to be like lines touching at a set of points, not just
Yes.
that would
Mhm.
be an intersecting line. I mean, honestly, I mean, you're just
Yes.
crossing over. So it
Yeah.
makes, you don't want it to cross to the other side. You just want it to gradually touch points and go continuous.
Absolutely.
Makes a lot of sense. I mean, I totally agree with you.
Yeah. So, but what is a radius of a circle?
So we're gonna start by let's just start at the very first step. When we're trying to find the radius of a circle,
Hmm.
we want to look at the circle and we want to know what the center is.
Okay.
So we're going to look and see that the center is 0, 0. That is, that's the very center of that circle. I mean,
Hmm.
and that could be, I mean, it could be any set of numbers, but in this specific equation, are,
It just
it's
happens to be
right on,
0, 0.
exactly. It's right in the middle. So that's 0. I thought it would be easiest to visually, see that.
Absolutely.
So
Hmm.
0, 0. And we see, we have our little purple line going to the right. We see that it's 0, 9. All
Hmm.
right. Well, we hit that again, we have, again, we have 0, comma, or, it goes up to 9. And then, if we go to the left 9 and we go to the bottom 9,
Mhm.
that means our radius of a circle would be 9. That means it's no matter around that circle, it wouldn't make it a circle if it went past 9. I mean, does that help a little?
Absolutely.
See it
Yeah,
visually.
absolutely.
So, like, if I have a circle, that wouldn't be a circle, if it went like all crazy.
Mhm. Yeah.
Crazy.
Yeah.
Well, that pretty much sums it up. I enjoyed this.
I sure did too. I think we learned a lot of ways to relate things to real world
Yes.
and show students, different techniques.
Mhm.
I'm definitely looking forward to our second team teach. I'm excited to see everybody there.
All right, we'll see you guys again.
Bye.
Bye.